Well, thank you everyone for joining us today for today's webinar, Strategies for Land Acquisition Related to Environmental Projects. My name is Jack Eskin. I am a senior program specialist at Delta Institute, and we will be delivering today's webinar with our partners over at Illinois-Indiana Sea Grant and Alliance for the Great Lakes. The intent of this project really is to clarify the process around strategic considerations, analytical considerations, and administrative considerations for land acquisition for environmental projects. In the work that our respective organizations have done throughout the Great Lakes region, we've seen this as an increasing need and priority across different communities and jurisdictions. And so it sort of necessitated creating kind of like a transferable resource from community to community, which is what we've developed and which is what we will run through today with you all. Some general housekeeping. Participants will be muted throughout the webinar. There will be a question and answer period at the end of the webinar presentation. So if you have questions that come up throughout the process, please submit them through the chat box and through the Q&A box, and we will get to them in that question and answer period in the end. If we don't get to your question during that period, we will answer them in a follow-up message that we send to participants after the webinar presentation. Also, something to highlight, in this post-COVID-19 world where webinars like these are being administered entirely remotely, in the event of a technology disruption or a technical issue, just be patient, and the webinar will resume shortly. Train will get back on the tracks and we'll have a productive session. So what are we covering in the agenda today? We're going to do a general overview and introduction of what went on for this project and what the process has been, really sort of talking about the purpose of it and the sorts of partnerships that need to be formed for it to be successful, the site selection prioritization process, how we modeled green infrastructure performance across these different sites using Sea Grant and Purdue's tipping point process and the L-THIA model, and then walk through the nuts and bolts of the land acquisition process, and then we'll conclude with a question and answer period. So who will you be hearing from today? Once again, my name is Jack Eskin. I am an urban planner that works at Delta Institute, an environmental nonprofit based in Chicago. And I will be joined by Ethan Brown, an urban planner who works for the Alliance for the Great Lakes as a community planning consultant, Kara Salazar, who's the assistant program leader and extension specialist for sustainable communities for Illinois-Indiana Sea Grant and Purdue Extension. She is also a planner. And Jingchu Chen from Purdue University, who is a postdoc research associate who oversaw the modeling through the L-THIA modeling process. So now I will transfer things over to my colleague, Ethan Brown from Alliance for the Great Lakes.
Thanks, Jack. This is Ethan Brown, community planning consultant to the Alliance for the Great Lakes, nonprofit, 100% dedicated to protecting the Great Lakes for its people and wildlife forever. Now, the purpose of webinar today is to share our process and how it was developed for Michigan City, Indiana. It's a great case study city for developing such a strategy. It's a small city of over 31,000 residents on the shores of Lake Michigan. Michigan City has a strong municipal leadership and engaged environmental stakeholders that together prioritize the health of the land and waters of Lake Michigan and local Trail Creek that flows into it. They see these natural areas, these natural assets, as critical to the quality of life of residents, their local economy, and their resilience to extreme storm events. Many of our slides today will frame not answers, but questions that help direct our approach, questions you will need to ask yourselves if you plan to embark on your own land acquisition strategy. Why acquire in the first place? What land characteristics matter most to you? Which land parcels are most suitable for your uses, and how can you acquire without making costly mistakes? This webinar is the culmination of a multi-year project. Funding for this project was provided in part by NOAA and the Indiana Department of Natural Resources Lake Michigan Coastal Program. The project team comprised of the organizations of Alliance for the Great Lakes, Delta Institute, Illinois-Indiana Sea Grant, and Purdue University, and the Michigan City Departments of Planning, Parks, Forestry, and our lead partner, Sanitary District. We solicited the input of a local land acquisition advisory group we convened, comprised of Save the Dunes, Indiana Chapter of Nature Conservancy, Shirley Hines Land Trust, members of the Trail Creek Watershed Partnership, and Northwestern Indiana Regional Planning Commission, and they helped us understand the acquisition process better. Now, our original purpose in developing this strategy was to provide guidance to Michigan City on why and how to acquire property for conservation and stormwater management. Two different but similar purposes. Now, we wanted to capture and distill institutional knowledge on the acquisition process so that future city staffers could avoid costly mistakes. And land acquisition strategies also help staff plan and align the acquisition process with funding timelines and constraints to maximize their grant eligibility and utilize that parcel acquisition as potential match for other grants. Lastly, developing a strategy can help bolster capacity for a city to prioritize and acquire the land it needs through normal means instead of having to rely on eminent domain, which is costly in time, money, and especially political capital. Now, the best way to start your process is to authorize it. It took us over 5 years from start to finish to complete the entirety of this project. Ensuring that there's a guiding light of formal authorization to complete this work is very helpful. Prioritizing land acquisition to address a public need is implementing Urban Planning 101. So we recommend embedding the need for a land acquisition strategy in your urban planning documents like comprehensive plans or in use-specific plans like a green infrastructure plan. If a suitable planning activity is not underway or too costly to start, you can always request your board, council, or commission to discuss, and if appropriate, pass resolutions in support of it. Michigan City Sanitary District Board passed its resolution to create a land acquisition strategy, which helped us obtain funding and continually helped us realign our project teams to those central goals of acquiring land for natural treatment of stormwater runoff and conservation of high quality habitat. Developing a project team, we recommend that the strategy is done through a multi-organizational team. For municipalities, it's important that a nonprofit is a close partner in order to provide significant capacity support throughout that multi-year time period. Having the expected acquisition entity, in this case, the sanitary district, as the leader of the project is key as well. We took a very collaborative approach that continually paid dividends, including bringing on Indiana-Illinois Sea Grant to help do the modeling, which is very successful. Once we had authorization to develop the strategy in our board resolution and our project team in place, we started working to prioritize which parcels to acquire first and why. Our process, led by Delta Institute, began with stakeholder and project team input into what we cared about, and that was followed by data analysis and reviewing, lastly, by the project team for feedback. Although we will go into detail about how we prioritize parcels in Michigan City, any process should have all of these fundamental attributes, beginning with what do you plan to use the land for, then identifying the features of the land which makes those useful uses most successful. For instance, if you want to acquire land for fishing access, then a river being within or alongside the parcel is necessary. Then you compare the land features you want with the data that describes it. Data that is complete across your entire geographic area that you're looking at. For instance, a municipality, that would be the municipal boundaries. That is critical. And importantly, when you are prioritizing, you will eventually need to intentionally weigh specific features of your data-driven process in order to index your parcels and sort them without any specific data type over-influencing or skewing the results. Checking in with your stakeholder team throughout is key. And eventually, once you have all of the parcels sorted and scored, the team should review the top parcels to make sure that each one really does have the features you desire. At this point of the process, you should gather your project team, especially all of those relevant to the potential uses of the property. If the eventual owner would be a municipality, then you would want all of your departments like planning, parks, forestry, stormwater, and sanitary districts present. If this is a land trust going through this process, then make sure to bring in any external partners that you work with, including county or city park departments, which may manage trails or properties that might be adjacent to the ones you might acquire. A discussion should be facilitated on the exact potential uses of the land to be acquired. For our purposes, we were looking at conservation and natural treatment of stormwater runoff using techniques like green infrastructure. Since we had separate uses which could potentially conflict, we decided to create two separate prioritization tracks. Conflict example might be that if you had remnant high-quality wetlands, you would not want to flood them with dirty stormwater from roads and parking lots that may have dirt or salt in the water. Now, the last point here is a critical one. After you have a clear idea of the property uses, begin to describe all of the features an ideal site would have. And sometimes it's helpful to describe those features as a story. For instance, if we wanted to conserve riparian ecosystems in the fictional community of Riverlandia, we would want an ideal parcel with a river through it for fishing access. And it would be great if that parcel was adjacent to already conserved land so we could extend a wildlife corridor. And if it was also close to a regional trail network, we could create a spur, an offshoot for people to bike to our new fishing spots. And it's always great to have a willing seller that believes in the spirit of your project. Now, creating little stories like this may be simple, but it helps crystallize for yourself and the rest of your project team the exact features that you would want to find representative data for. And that helps you immensely in your next steps. Once you have used story time to develop a list of all the site features you're interested in, now is the hard part, matching up your wish list of site features with spatial data that already exists and is complete. Make a list of all the site features on one side of a blackboard, and then identify the data sets and sources available that most accurately describe it on the other. It's always best to have any city or county GIS staff in the room for this conversation, as they'll know the data sources available best. Inevitably, you will have site features that you do not have data for. Some data types, like fishing access sites, for instance, may be so few in number for your area that you could realistically create new data sets inside of your software like ArcGIS, or you could go geolocating on site and create the files that way. For other missing data sources, you can get creative using proxies that can represent the site features you care about. For instance, you may be most interested in conserving remnant ecosystems that have been untouched, but do not have extensive surveying or floristic assessments at hand to describe those areas. So instead, you may choose to score parcels that are unimproved or without freestanding structures like buildings as higher than those with structures. And your assumption would be that properties that have not been built upon may have a greater likelihood of containing untouched ecosystems as well. Now, proxies are never perfect by definition, but they can help narrow your choices, which is what this entire process is about. You know, many municipalities, you are going to be wanting to winnow down tens of thousands of parcels to a manageable few for in-depth evaluation, and this can help. In our Michigan City case study, we identified the following data factors and grouped them into subcategories in order to weigh them later in the process. To determine how ready a site is for acquisition, for instance, we looked at whether it was within a TIF district or a tax increment financing district, which can open up additional funding sources for acquisition for greater financing flexibility. Or for whether a parcel is suitable for managing stormwater, the presence of an outfall to collect that stormwater is extremely valuable. And lastly, for whether a site is suitable for conservation, being located adjacent to existing managed or conserved lands is a big plus, as we could extend that conservation corridor through acquisition. In Michigan City, we had two intended uses, so we scored the factor categories differently depending on those uses. Not surprisingly, green infrastructure uses prioritized stormwater management over recreation. This is the process of intentionally weighing your data factors. I really want to stress here that you should always weigh your factors of an index that you create, because choosing not to weigh them is as much a decision as weighing them intentionally, and you should always be intentional. We chose these percentages based off group conversation of what was important for the planned uses for the group. And you should do the same with your team and create your own weighing schema and percentages. For those not steeped in spatial analysis, I'm trying to make this as easy as possible. When using data to prioritize parcels, you may want to normalize or change the data in a way to factor into your spatial analysis. So often that can mean creating new fields for all of the parcels you're looking at, where you make qualitative data quantitatively usable. For instance, coding improved properties, those with buildings, as ones, and unimproved properties as zeros. Normalizing is necessary as some factors, due to the nature of that data type, can disrupt your index. Like, for example, whether a property is next to conserved land is a binary yes or no, or a 0 or 1, right? Now you compare that to a large property, tens of acres, which might have 5 or 6 fishing access sites or stormwater outfalls within it. That discrepancy in the number ranges can skew your results. So normalizing the data and weighing them helps smooth out data type discrepancies to get closer to the spirit of what you are seeking to find, the parcels that are most useful for your purposes. Then you can add up all the scores based off of your weighing schema you create. As we scored all parcels for 2 separate uses, we then compared those 2 scores to see which parcels scored the highest across both of them. The top 20 parcels that had the highest scores for both of those uses were identified and selected for stakeholder review. And we brought everyone back together to review these top 20 parcels. And this is the qualitative review of the quantitative analysis, and it's absolutely necessary. Sometimes the data may be correct, but still doesn't tell the whole story. For instance, one high-scoring parcel was thrown out as a local group owned the parcel and already was stewarding it for locals to fish there. It was understood that they would likely never sell it, and were already fulfilling the parcel's best use as a fishing spot, so there was no need for the city to acquire it or to keep it in for future analysis. While we had the project team together, we also asked them to evaluate each parcel and identify which areas of the parcel would be best designated for conservation or recreation uses. They then physically drew on paper maps, and these cutouts, these drawings that they drew on the maps, were later digitized and pulled into our analysis. These were very large parcels, sometimes dozens of acres large. So splitting them up into separate uses, one side of the parcel being used for green infrastructure, the other side being used for conservation, that was possible. The purpose of this was to send the cutouts of each parcel over to Illinois-Indiana Sea Grant for further modeling. The areas not designated for conservation would be analyzed for the purpose of green infrastructure practices. This way, if acquired, we could still install both uses on a parcel, maximizing the public use for a costly acquisition. Now, Michigan City has been very interested in the idea of using multiple uses on a single project site. This project I'm about to describe right now, the CHENEY Run Wetland Project, actually began during this strategy's prioritization process and was not a direct outcome of the land acquisition strategy. However, we wanted to highlight an example of putting the spirit of this strategy into play. The CHENEY Run Wetland Project in Michigan City is designed to use newly created and restored wetlands to absorb and filter stormwater before it reaches Trail Creek. Along the creek are a series of trail and fishing access sites, and across the creek on the other side will be a restored native prairie ecosystem across from the wetlands. This is a very simple design of the site, where the wetlands contain green infrastructure site that absorbs the water from the CHENEY Run Channel. Now that's a channel that drains roughly 3.7 square miles of Michigan City, mostly urban runoff. It absorbs the water in the channel before it reaches Trail Creek. Now this site's much more complicated than described here and might be the subject of a future webinar, but this is an example of how Michigan City might acquire land in the future and implement both green infrastructure and conservation at the same time. Now, I'd like to pass the baton to our friends and partners over at Illinois-Indiana Sea Grant.
Hi, thanks so much, Ethan. This is Kara Salazar. I'm an assistant program leader and extension specialist for sustainable communities. I'm also a certified planner. My area of focus is environmental planning, land use, and community development. The work that I do through Purdue Extension and Illinois-Indiana Sea Grant with multidisciplinary teams supports local government planning, implementation efforts, and policy development for land use and sustainable development. The work that we do also focuses on comprehensive plan updates, watershed planning, parks and recreation master plans, and land use planning. And today I'm going to talk to you a little bit about our Tipping Point Planner program, which is the avenue in which we participated through this project with advanced modeling efforts through Jingchu Chen, who is going to speak after I will. Tipping Point Planner is a decision support system which has a Great Lakes-wide focus. This is the culmination of the collaborative efforts between over 25 scientists, extension professionals, and community leaders who have been working to apply research to solve community issues. Our work is supported by NOAA, the Great Lakes Restoration Initiative, and the EPA's Great Lakes National Program Office. And as a result, our teams are available to work throughout the Great Lakes states, and we will have some virtual offerings available in August. So we are working hard to pivot from in-person to online as well, like many others. And excuse me while I get my technical difficulties going. So thank you. We developed this program, Tipping Point Planner, to identify ecological tipping points, which are changes in the conditions of the environment that are difficult or impossible to reverse. Our ultimate goal is to protect and restore watersheds in the Great Lakes. And through a series of needs assessments and focus groups, our teams identified several challenges affecting water quality in the Great Lakes region. And they include land use changes, including the increase of impervious surfaces, nutrient loading from agricultural landscapes, and stream health and food web health. And as a result, we created this decision support system with a menu of topics and options to address local planning needs. So our teams will, when we are working with a community and a group, we identify what's needed and we go through these different types of scenarios to support local efforts. And these 6 overarching topics that we work from include working through stream health models and using index of biological integrity to look at changes. We also have several different nutrient loading models. We have scales available for hydrologic unit codes 8 and 12 using SenseMap modeling from Michigan State University as well as Sparrow modeling. We have several different options for working with land use change using work through Purdue University, looking at how scenarios impact health of watersheds. Our food web work focuses on nutrient loading that and impacts on aquatic species. And the main focus of what we're highlighting today is the work around green infrastructure. And in our decision support system, we offer scenario planning to optimize green infrastructure placement. But again, Jing Chu is going to discuss the more in-depth modeling process that she went through in collaboration with our program partners on the webinar today. For our Tipping Point Planner program, we do emphasize diverse participation, and we offer a facilitated series of workshops to bring together the target audiences listed here, as well as research staff. Purdue Extension and Illinois Indiana Sea Grant staff serve as those facilitators and move through the planning process. And again, we support projects such as comprehensive plan updates, land use planning, and watershed management planning. As we're going through this collaborative action planning process, we're using community development and planning best practices for facilitation and community engagement. And as a result, we have different types of options to help communities go through the assembly of the steering committee, working group and visioning workshops, and all different kinds of working group meetings to get to a final plan. We very much will integrate the community vision with science and data from the Tipping Point Planner models to apply to local planning process. We also have some new and different types of options through our Tipping Point Planner. We have the full decision support system, which is highlighted in the middle here. We also have new regional planning dashboards that work at the basin scale. That are filtered through watersheds. And then we also have county planning dashboards, which are available for each county in Great Lakes states. And this is a nice snapshot to look at different types of features for land use planning that draws from the modeling and features from our decision support system. And all of this information is available on our tippingpointplanner.org website, and our regional planning dashboards and county dashboards can be found at the address below. And again, I am happy to take questions and talk more about our planning process. But first, I'm going to hand it over to Jing Chu so she can talk more about the work that she did through this modeling effort.
Thanks, Kara. Good afternoon, everyone. My name is Jing Chu Chen. I'm a postdoc research associate working at Agriculture and Biological Engineering Department at Purdue University. My research focuses on hydrological modeling, sustainable water management, and decision support tool development to assess impact of alternative land and water uses. I'm very glad to have this opportunity to share this exciting work focused on hydrological modeling for land acquisition strategy with you today. It has been a great pleasure to work with my colleagues, Dr. Yaoze Liu, who is previously a postdoc at Purdue and now is an assistant professor at the Department of Environmental and Sustainable Engineering in University at Albany. And my supervisor, Dr. Bernie Engel, who is Associate Dean of Agricultural Research and Graduate Education at Purdue, and also Professor at Agriculture and Biological Engineering Department. So I will start with some background. Green infrastructure practices, they are on-site stormwater management approaches which can increase infiltration and storage, delay runoff peak, reduce runoff rate and volume, and control the movement of pollutants, including large-scale best management practices. We usually call it BMPs, and small-scale low-impact development, LIDs. So the overall goal of this research is to provide recommendations for the land acquisition process in the city and to identify parcels that have greater potential to achieve more environmental benefits. The large-scale BMPs usually can achieve greater environmental benefits comparing with small-scale LIDs. So in this study, we consider 3 types of BMPs in the research. The first one is detention basin. We also call it a dry grass lined basin. It is designed to be completely empty during the period between storm runoff events. The second one is retention pond, which is also called white ponds. Those ponds are never dry, and the water in ponds is replaced to a degree or completely by stormwater for the period of storm events. The third one is wetland basin. It is an area filled with water, both permanently or periodically, and it's covered with wetland vegetation. Since there are 20 parcels that are available for hydrological modeling for this work, we first conducted an initial screening to determine competitive parcels that are more valuable for hydrological modeling by considering multiple criteria, including by using the satellite image to see is there any BMPs that are already existed in the nearby area, and also look at the suitable areas for implementation of BMPs, and also look at the drainage area for each specific parcel. The long-term hydrological impact assessment, low-impact development, which is L-THIA LID model, was adopted for this research. The L-THIA model was first developed around 1994 at Purdue, and it has been widely used in different countries by scientists, city engineers, and decision makers. More than 60 peer-reviewed journal articles about this model development, enhancements, and also applications are published, and these articles are cited more than 3,000 times by researchers all over the world. So I have about 6 years of experiences working with this L-THIA and also L-THIA LID model. So the figure on the right side, upper right, for a specific grid, the land use type and the hydrological soil group can decide a unique curve number, and then we use L-THIA curve number method to estimate the runoff depth, and by multiply the cell size, we can calculate the runoff volume, and then combining with the event mean concentration method for each land use, we can estimate the non-point source pollutant loads. So the LCL LID 2.1 model, which is used for this research, can evaluate the performance of BMPs and the LIDs at the watershed scale. And there are a total of 12 green infrastructure practices are represented in this model using different runoff estimation methods as showed here. So for small scale LIDs, the model used modified curve number method. And for larger scale BMPs, this model used percent runoff reduction method for the runoff estimation. And then we use multiple data for this modeling work. The first one is precipitation. The daily precipitation from 1998 to 2017 was used for the modeling purposes. And then we downloaded the National Land Cover Data Set 2011 version for the modeling work. And we also use the Circle database to extract the hydrological soil group information. And other data that are considered in this research include digital elevation model, streams, and imperviousness layers from NLCD 2011 dataset. And then here in this table, it shows you the site suitability criteria that we used to select the suitable area for a certain BMPs, considering drainage area, drainage slope, imperviousness, hydrological soil group, and stream buffer. So the total cost and the cost effectiveness are also included in this research. The total cost was calculated by considering the construction cost, maintenance cost, interest rate, and a design life of 20 years for a certain green infrastructure practices that are used in this research. Cost effectiveness were evaluated using cost per unit reduction per year. So for example, in order to reduce 1 cubic meter of runoff, how much money that need to be spent for 1 year. And then the table here shows you the construction cost and annual maintenance cost that are adopted for this research for wet pond, dry pond, and wetland. And we simulated 4 scenarios for competitive parcels in this research. The first one is if all suitable areas in one parcel that is implanted by wet pond, how or what the performance will be. The second one is if we use all the suitable areas of BMP to implement a dry pond, what are the environmental benefits? The third one is if we implementing wetlands in all suitable areas in one parcel, what the performance are. And then the fourth scenario is to model 3 BMPs, including wet pond, dry pond, and wetland equally. They are equally implemented in the suitable areas. So before doing any modeling work, this model was calibrated, used the nearby watershed data, which is Creek Watershed, since those areas shared similar rainfall patterns, similar topography, and they have similar development or land use types. Now let's see some of the results. So previously I talked about the initial screening of the top 20 parcels before we conducted any hydrological modeling work. So this map here shows you the locations of those top 20 parcels, and we grouped them into 7 groups based on their locations, and by considering multiple criteria, we determined 6 parcels that are more competitive compared to others, and then we were going to use those 6 parcels for the hydrological modeling work. So this table summarizes the information of the area of the parcel, the drainage area of a parcel, and also suitable area for BMPs if implemented in each parcel. So if you look at this table, when you say from the last 3 columns, the percentage, if a number that exceeds 100%, that means this parcel is capable of processing all the runoff coming from its contributing drainage areas. So let's see some of the results for the runoff reduction and the cost effectiveness. So for 6 parcels that are modeled in this research, we aggregate the runoff reduction in average annual value. In each parcel, the scenario 2, which is dry pound, which is the dry pound or implemented to all suitable areas within the parcel. This scenario can achieve the greatest runoff reduction, and it also can consider as the most cost-effective options for runoff reduction. So if we look at the parcel 4 here, which has the greatest runoff reduction if implementing the BMPs in this parcel. So for this parcel, dry pound is the most cost-effective scenario and also can achieve greatest runoff reduction among others. And then the next slide is showed you the total suspended solids reductions as represented by average annual reduction, and also the cost effectiveness for each parcel. And here, again, compared to the runoff reduction for sediment, the wet pound can achieve the greatest sediment reduction, as shown here as S1, the first scenario, and it is also the most cost-effective options for sediment reduction. And the dry pound in those simulations also could achieve substantial reductions. And some of the takeaway messages from analysis for runoff reduction and the sediment reduction, well, we have other simulations for total nitrogens and total phosphorus, but for today's presentation, we included only for runoff and sediment reduction. So the dry pound can achieve greatest runoff reduction, and also it is the cost-effective option for runoff reduction. For sediment, dry pound can achieve substantial reduction. However, the wet pound is the most cost-effective option, and it can achieve greatest sediment reduction. And generally speaking, the parcels with the larger suitable areas for BMPs and large drainage area that flows through them provide the most significant opportunities to address runoff and the water quality issues, as the amount of flows and the pollutants that could be mitigated with green infrastructure practices or even large-scale best management practices is larger. And also, connecting the parcels with adjacent ditches could increase the potential of the runoff and the sediment reductions. So those are some other thoughts that can be considered beyond the study. So that's it for the modeling work I want to go through today. Welcome to ask any questions if you have. Thank you.
All right. On to the acquisition process. So this is the final chapter of the report, and it's also the final chapter of today's webinar. Ethan has sort of walked you through some of the strategy around how to select and prioritize different sites throughout this process. Kara and Jingchu talked about how to model and evaluate performance in terms of green infrastructure of different sites that you'd want to move forward with. Then there's the actual process of acquiring the property. So we're going to take you essentially through Real Estate 101 for environmental acquisition. The intent of this process is to provide as much clarity and simplicity and predictability to a process that is rarely a clear point from point A to point B. In the land acquisition guide, we've laid out essentially a checklist, fairly robust one, of questions to ask, studies and surveys to commission to be able to get complete understanding of the opportunities and risks around potential site acquisition, and then leading to the later stages, what needs to go into a specific letter of intent and a purchase agreement. We will start with information gathering. Generally speaking, you're looking to gather as much information about your parcel's economic data, environmental data as possible. This might even include doing some specific environmental history site investigation and engaging with the landowner around the potential acquisition. Once again, the overall intent of this process is to reduce the amount of time, the amount of money spent on acquisition by less experienced municipal or public agency staff. Folks working in local government, oftentimes site acquisition for environmental projects is not necessarily the bread and butter of what they're doing. And so there's a variety of processes and considerations that need to be undertaken to be able to do it clearly and effectively. The information gathering stage essentially predates or comes before the letter of intent and the purchase agreement. This involves collecting as much information as possible, contacting the landowner, investigating environmental history, and then reviewing any potential red flags that could serve as a barrier towards moving forward. So the information gathering stage, in reality, the majority of the information that you may likely need could come from publicly accessible records, either from the county assessor, the recorder of deeds, the surveyor, or a variety of other state, local, county-wide sources. The overall intent of this process is to identify the specific benefits that could come from this acquisition, as well as the different burdens and restrictions that could sit on it. This is a form of ground truthing, there might be an opportunity to do a lot of site restoration work related to wetlands or existing forest on site, and the information that you gather will reflect that. There also might be tax liens. There also might be utility easements. There also might be existing structures on site, or even underground storage tanks. And a lot of the information that you gather will determine what the cost benefit is of undertaking this project. Then the follow-up is obviously contacting the landowner. It's best to be able to do a site visit with an evaluation checklist that's provided in this report. And it's an opportunity to identify problems relating to pollution, but also potential restoration opportunities that exist on site. Particularly if you're looking to fund the acquisition through a grant, obtaining a willing seller letter from the landowner is a key portion of this process as well. Environmental due diligence is advised at this stage. Some of that can be undertaken through an in-house assessment of public records, but it may involve also conducting a phase 1 or phase 2 environmental site assessment to be completed by an environmental consultant. The phase 1 environmental site assessment is oftentimes completed by doing desktop research on environmental databases. A phase 2 is literally oftentimes taking soil samples and doing lab research on the contents of the soil, whether there's any contamination. Particularly for grants from agencies like US EPA, oftentimes doing a phase 2 is a requisite for receiving a grant, particularly for environmental cleanup. There's also the need at this stage to consider any potential red flags around whether there's challenges to the title ownership, whether existing easements are in place that complicate use of the property, whether the fair market value of the site makes acquisition cost prohibitive for a municipality, whether family trust ownership of a particular property and whether that makes it hard to contact the specific key seller is a complication on the site. And if you're working in a post-industrial context, whether you're dealing with legacy contamination issues and whether a site is potentially a brownfield. Also, from a fiscal standpoint, if the property has tax liens on it, if it's in bankruptcy court, that might complicate the process of acquisition as it regards to getting a property from existing landowners. The next stage is moving on to the letter of intent and ultimately the purchase agreement, and we will run through the guidelines of that. So a letter of an intent is a non-binding expression of intent to purchase. It essentially sets the table for what will be agreed on in the purchase agreement. The property gets removed from the market. You've set the table to be able to negotiate the terms of the purchase agreement, and it's a wonderful opportunity to be able to integrate a prospective purchaser's grant guidelines and timeline into the negotiation process. Part of what gets negotiated in the letter of intent is the value of the property. Typically, this is established through 2 appraisals that are completed to establish fair market value, which cannot exceed the average of those 2 appraisals. These typically take 2 to 3 weeks to complete. They're relevant for 6 months. They can be commissioned by either the seller or the purchaser. Of course, they can be dispensed with at any point if they're viewed as not being accurate or realistic. It also is an opportunity to establish the terms, the period of exclusivity for negotiation, confidentiality, the feasibility period for due diligence, things of that nature. This all leads to the purchase agreement, which, unlike the letter of intent, is legally binding. For a public agency like a municipality, this would be reviewed and approved by the legal department. If it's a city attorney. It sets the feasibility period for due diligence, the seller's materials, the financing contingency, and other core components. So while environmental site assessments are recommended for the investigation stage, they are absolutely essential for the purchase agreement stage. You'd be completing a phase 1 and phase 2. Also, you'd be conducting a title investigation to establish whether there are any legacy interests on the property that complicate obtaining clear title and ownership over the property. Once clear title has been established, it's conveyed through a warranty deed at closing, and it's a core component of establishing clear, uncomplicated, fee simple ownership over a property. In conjunction, a survey will need to be completed that identifies both the boundaries and the improvements on a particular property. If there are no structures or easements or other clear improvements on a property, a basic boundary survey will work. But if there's a lot of those core components, an ALTA survey, which captures more detail, is necessary. The purchase agreement will set the procedures for what objections or contests are made to the survey throughout the process. And a core component of it is establishing legal access to the property. The purchase agreement will also establish the feasibility period, how much of the purchase price gets set aside into escrow, and any necessary parties that need to endorse the survey. There are also various negotiable elements to the purchase agreement, including financing contingency, the timeline for approval, if there's any remediation that needs to be conducted on site, who's responsible for that, and who has signatory authority. So all of these conditions will be closed on before closing day. They will receive approval before closing day occurs, much like the closing of your home. This will be executed between the purchaser and the seller by a third-party title company that will evidence the state of the title and hold the earnest money for deposit. The title commitment gets approved by both the legal counsel of the seller and the purchaser, and upon execution of the purchase agreement, the title company will take the deed to the recorder's office for recording, and all of the necessary closing documents are held by the relevant departments after execution. So what are the primary intended outcomes of this process? It's intended to significantly reduce risk and uncertainty, and really the soft costs of acquisition throughout the process. It provides a framework for doing extensive due diligence and providing as much information on the site as possible before execution of any acquisition. It's intended to provide predictability and transferability from one process to the other, as well as making it manageable for staff who are undertaking this sort of exercise for the first time. And it's intended to be replicable across different government agencies. If you skip steps, you essentially open yourself up for risks. If you don't undertake environmental due diligence, you may end up with contaminated soil or structures, or like you see here, underground storage tanks on the property. If you don't do certain types of due diligence, you may end up with significant delays to the project, as well as impacts on your grant timeline. This can lead to added costs from contractors and change orders. If different amounts of research hasn't been undertaken on what sort of districts you're in, you may be subject to different special taxes and fees. And then there's questions around boundary lines and the extent of a parcel's boundaries and ownership. You can end up with contested boundary lines. There might be legacy interests that may still be on the property that would be revealed by a title search that you may be subject to if the necessary title work is not completed. If the process is not particularly transparent, it can be contested by different members of the public. And of course, if not managed in the right way, you can receive or experience competition from different real estate speculators that aren't necessarily moving forward with the greatest public interest in mind. So there are a lot of risks to mitigate, and by having a sort of clear, extensive process, you're able to accommodate for all those different risks in completing a project. So those are the nuts and bolts of what's in the guide, and we've come to the point where we are going to move through different questions that we've received If any questions come up through the process of viewing this webinar, please submit them through the chat box, and we will answer them one at a time. So the first question that we received, this is for Ethan. What is most transferable about this strategy document from community to community, and what translates to a larger municipality versus a very small one? Do you want to take that, Ethan?
Sure. This is Ethan. I would say what's most transferable about the strategy with regards to the prioritization part would probably be the data analysis. And that's because any municipality can do this because there's already significant spatial data sets out there, from federal all the way down to city data sources. So there's already a really robust data set out there, data sets that you can use to build out your model on how to prioritize those top parcels. And the skills required to do that, from data cleaning to gathering it to normalizing the data, while you do need skilled GIS staff to do it, it's not the upper echelon, I would say, of spatial analysis. Like, I know how to do GIS pretty well. I can do this. There's a lot of spatial analysis I have no idea how to touch. So it's definitely something that like a city GIS coordinator can do, but the process of normalizing the data and changing it in a way to make sure that one specific data type, like the presence or proximity to a river, for instance, doesn't skew the data, but still has value into the overall results. That's what's the tricky part, and that's what requires the conversation with cities, the acquisition party staff. For what translates to a large versus small municipality, I would say the real difference is in capacity. A larger municipality has significant capacity to be able to push this forward, to be able to do the analysis in-house, or to even create new data sets to describe what they want. Whereas a small municipality will really need to work and collaborate with a lot of external nonprofits and local watershed groups to get the capacity and staff expertise. However, with a larger municipality, you are going to need to bring in more issue and area specific stakeholder groups to make sure that all areas are represented. And that can potentially extend the timeline that you're looking at. And also you have just much larger geographic footprint, maybe several times larger total parcels to look at. So I hope that answers that question, and let me know if there's any follow-up that might be valuable.
Great. The next question that we've received is a copy of the checklist for acquisition process available on the web. We have added it on Delta Institute's website. While we haven't provided the URL here, it will be shared with the webinar participants in a follow-up email, so that will be available for use. Our third question that we received: I'm working on an urban forestry project for Indianapolis. I'm wondering how land use regulations through zoning, subdivision, or other tools can be crafted to minimize the tree canopy loss, or what tools are available for people to design better development site plans to minimize tree loss. It's a slightly different question than the question of acquisition, but it is related from the standpoint of how do you, instill and reaffirm environmental improvements and benefits within a developed context. What I would say is that any sort of development guidelines that focus on the right-of-way, focus on setbacks, and focus on just the nature of development are going to be key tools in making sure that trees are preserved through the permitted development process. Permitting is one of those things that doesn't attract a lot of attention from a lot of planners in terms of being the most exciting part of the process. But oftentimes when you're talking about, preserving trees as new subdivisions are being cut or redeveloped, it's a key component. Kara, Ethan, anything you'd like to add?
Yeah, hi, this is Kara, and I just placed in the chat the link to a guidebook series that Purdue Extension and the Indiana Land Resources Council developed last year. It's called Community Planning for Agriculture and Natural Resources, a guide for local government. And we have an urban forestry section to that that was led by Lindsay Purcell. And it's titled Urban Forestry Comprehensive Planning Guide. So I think a lot of things that you're looking for will be in that guidebook section to get started with. And it also has resources for a lot of different elements too for tree preservation. And Lindsay Purcell is also a great resource. So I hope that guidebook is helpful.
Awesome. All right, another question we have for Jing Chu. What are some basic assumptions for the L-THIA model, and how does it manage its own bias?
Yes, so L-THIA is a easy-to-use, user-friendly model compared to other sophisticated model that requires substantial data input. So here in this model, we assume the water flows across the surface to the flowshed, and we assume water equally spread across landscape. So that means no rotting process in this model. And the third assumption is we assume soil is not saturated or frozen when we do modeling, and then rainfall is evenly spread in the local area. So in order to reduce the bias, so the result we are looking at long-term averages instead of the daily time series, even though the model started with calculating runoff and nutrient loading using daily values, but the final results are presented as average annual value. So that builds more credential to look at the results. And then the other uncertainty that existed in the model is the total cost estimation. So for different locations, the initial construction cost can vary a lot, and the model does have the ability to accommodate those uncertainties if we have those price estimation. And then I want to clarify that the price we're talking here is only for the construction, maintenance, the BMP, the best management practices in a certain time period. It does not include any money that related to purchasing a parcel. Yeah, so that's it.
Great. Another question that we received, what are some of the most common pitfalls in the acquisition process? I would say from my end, it's the desire to move fast and all the corners that you cut as a result, particularly with environmental investigation and assessment, and the fact that sometimes there's a competitive, time-sensitive nature to land acquisition. There's a viewpoint that certain studies and surveys are a little bit perfunctory or not even, or maybe even not essential. Certainly, resources in municipal governments are finite, and so there's not a desire to sort of waste all of your limited discretionary resources on understanding every little element of your parcel. At the same time, you foreclose on being able to participate in certain opportunities like grant-funded programs when you don't do the full extent of your due diligence. And so I would say, particularly around environmental assessment and moving too fast, that's a common pitfall. One final question that we've received to Kara, should strategies like this one drive regional watershed planning, or should the reverse be the case?
So it's a great question because planning is complex. This is a very multi-step process. And so when you have an engagement process where you can break down the steps, you have opportunities for education and for engagement, then that does open up the doors for more collaboration. So you can have diverse interest groups, things that were mentioned throughout the presentation come together. You can have the opportunity for some shared decision making. You can also, what's really important through this type of a process is not only identifying community needs and values, but you're also matching that up and overlaying to environmental prioritization as well as overlaying with preferred implementation strategies. So I think that, in my opinion, it's good to have a strategy like this for regional planning as a practice to follow, so that you really are identifying some of the pitfalls before you are moving forward into implementation. So I'm happy to take follow-up on that too if needed.
Great. Well, we've come to the end of the webinar today. We, apologize for going over 7 minutes, but we got some good questions. If folks have any follow-up questions for any of us or would like more information, our contact information will be available in a follow-up email, and it's provided on the slide here. But thank you so much for joining us today and walking through the land acquisition strategy. And we hope and we feel that it can be a really sort of valuable resource in helping municipalities, public agencies, and local stakeholders looking to implement environmental projects in being able to do so effectively. So thank you for joining us today, and stay safe.